Okay, so last time we left off with this exercise to find the average rate of change of the function 2x plus 1. So what we want to do is we want to compute f of a plus h minus f of a divided by a plus h minus a. So this is going to be the average rate of change, and what we're going to see is actually this is the average rate of change is going to correspond to the slope of the line. And that's going to be the case for all lines, but let's just see it explicitly for this particular example. So what is f of a plus h? This is 2 times a plus h plus 1. So that's f of a plus h minus 2a plus 1. Remember that we have to distribute the minus sign on the entire f of a, divided by, and then we have the a's canceling, and we have an h at the bottom. So what we get is 2a plus 2h plus 1 minus 2a minus 1 all over h. And notice that the 2a cancels with the negative 2a, the 1 with the minus 1, and what we're left with is 2h over h, which is equal to 2. And notice that this corresponds exactly to the slope right here, which is 2. And that's no coincidence. So given any line, and we'll say it's in the form y equals mx plus b, the average rate of change is equal to the slope. Is equal to the slope m. So a line essentially has a constant rate of change. And that constant rate of change is just the slope. So what we're going to do is we're going to end here with a little exercise for you to try an application. So, and we'll do this this kind of leads naturally into the next section. So let's say you have an oven, and at time 0, the oven is at 70 degrees. So the temperature we're going to denote by capital T. The temperature is 70 degrees Fahrenheit at time 0. And let's say after 10 minutes, so time here, little t, is in minutes. After t equals 10 minutes, little t, the temperature is 400 degrees Fahrenheit. Now, what we want to do is, so we're going to assume that we have a constant rate of change, assuming a constant rate of change. What we want to do is, we want to find the rate of change. So find the rate of change. And part 2 is going to be, well, now that we know that there's a constant rate of change, how long will it take to reach 500 degrees Fahrenheit? Okay, so we're going to end here with this exercise. So essentially here, capital T is a linear function of little t, and that's what we're going to use to do this problem. So we'll stop here with this video, and we'll start with this exercise in the next video.